Hello everybody, Ben Woodruff here. Today's video is a video that I've had a lot of people around the world asking me to make this video today because some exciting news has happened. In the news, you probably noticed the past few days, Colossal Bioscience has announced that they have cloned and brought back from extinction dire wolves. And I've had a lot of people reaching out to me, people asking my views and opinions on it, and also my involvement at Skinwalker Ranch with a specimen that has the potential to be a dire wolf, and people asking, is that where the samples came from to make this, because Colossal Bioscience was the company testing the samples that we got from Skinwalker Ranch. So I'm making this video to set the record straight on all of this stuff and to teach a little bit and to kind of get people up to speed on what is really what. Now, that being said, I have had to fill out and sign non-disclosure agreements, so I will be very cautious to not say anything that I'm not allowed to say at this time. There's a lot of stuff that I'm not allowed to talk about at all, and a lot of stuff that is going to be coming out in the coming months, and I will not talk about those things on this video. So I've thought things through to make sure, to be very sure we cover this. So let's talk about first, what is a dire wolf? A dire wolf is an Ice Age megapredator. It's a very large member of the canine family, and you can kind of take a look at this skull here. Dire wolves are very common all throughout North America, and they're very famous through a lot of movie franchises as well. So first thing I want to say, dire wolves were a megapredator, but they were not like the size of a horse. You see them on movies as these giant, enormous things. They were bigger than a gray wolf, but they were not absurdly big. You know, this isn't that much bigger, but they were larger. They were more robust. They're a little more stocky, more powerful of a bite. The sagittal crest is bigger, more powerful, and they are a species that evolved here in the New World. If you go down canine lineages, the gray wolf branched off from dire wolves about 8, 9 million years ago, give or take. They're still very closely related, but they branched off, as did many other species of canine. So here in North America, we had a lot of super predators. This is the other famous one, right? The saber-tooth, the Smilodon. He's not a tiger, it's the Smilodon fatalis. State fossil of California, kind of an interesting animal. If you know me, one of my biggest passions is the Ice Age. I study it. I have a vast collection of real and cast specimens from Ice Age animals from all around the world. And the Ice Age is a time right before us. It's from about 1 million years ago until, give or take, 9, 10, 11, 12,000 years ago. It depends on what field of science you are in. If you're a climatologist, if you're a geologist, if you're a paleontologist, if you're an archaeologist, you measure that cutoff date a little bit different. But here's what you got to remember. Every animal that is alive today, every species on the planet that is alive today was here during the Ice Age. Now, most of the Ice Age animals did not survive to our time, but everything left is an Ice Age animal. And you might be like, what about tropical animals? Yeah, Ice Age does not mean the entire planet was all icy. The North Pole and the South Pole had more ice, so much so that the oceans were about 200 to 300 feet lower than they are now. But there were still tropics, along the equator. They were just more limited than they are now. So all the animals we have today, animals do change. They do evolve over time, but not enough time has happened. So even domesticated animals like chickens, yeah, the chickens we have today they were domesticated by humans at the end of the Ice Age, but they came from wild jungle fowl in Southeast Asia. What about cows, cattle? Moo, seems like a very domesticated animal. Nope, they came from the wild aurochs of Europe that, again, are such a recent extinction. The last wild auroch was killed in the 1600s. So a lot of these animals are very recent extinctions. A lot of these animals, we know for a fact that humans killed them off. One of the ones we're going to be talking about in this video is the thylacine, or the Tasmanian tiger. I do not like calling them a Tasmanian tiger because they're not a tiger. They're not even a cat. They're a marsupial. So growing up, everybody called it a Tasmanian tiger. Now people are starting to call it what it is, a thylacine. It's a marsupial predator. This marsupial predator lived throughout Australia and throughout Tasmania and throughout Papua New Guinea. It was killed off in Australia and outcompeted for dingoes. They were in Tasmania into the 1900s, where they were presumed to have been hunted to extinction. There is a chance that there is still a population of thylacines in Papua. And a famous biologist named Forrest Galante has been spearheading legitimate probability that there is a tiny, small population there. But companies like Colossal Bioscience are also trying to bring back thylacines from extinction because humans caused their extinction directly, but also indirectly with things like bringing dingoes to the Australian mainland. So let's get back to the dire wolves here. During the Ice Age, there was all kinds of animals. We know the climate has been changing the past 10,000 years. Most of Canada was under like a mile or two deep of ice, like the whole continent. So things have changed comparatively rapidly. When we talk in science, there's a lot of big numbers, and it's easy to think 1 million years seems like a long time. It's not. The Ice Age only started about 1 million years ago, and it ended, around 10,000 years ago. That's not very long ago. It really isn't. So the animals we have today are the same animals that were around during the Ice Age. There just used to be more, like the dire wolf. And the dire wolf and the gray wolves did not turn into dire wolves. These are cousins, and one is gone and one is still around. Same thing. Woolly mammoths did not turn into elephants. Woolly mammoths were a type of elephant that existed. And so are African and Asian elephants today. These are cousins, but some of them are gone. In America, we had several. We had woolly mammoths, Columbian mammoths, steppe mammoths, gomphotheres, platypelodons, and mastodons. We had lots of woolly elephants. They're gone now. We do know that humans hunted these. There's a big debate with a lot of these extinct animals. Did humans kill them off? Some people are like, well, yeah, of course. And some people are like, oh, I have a hard time believing that humans could have had that impact. It could have been other things too. There's all kinds of factors. That's going to come into our discussion in a minute. But what is a dire wolf? So a dire wolf is related to gray wolves, but it branched off early on, and it was an American species. The gray wolf, meanwhile, was over on the other side of the world, and when the oceans got so low at the beginning of the Ice Age that you could cross over the Bering Land Bridge, then you started to have gray wolves come back to America for the first time in millions of years, and they formed direct competition with the dire wolf. We don't know how this impacted things. We don't know if they just outcompeted. We don't know if some of them were hunted. We don't know. But we have tons of specimens. If you go to the Brea Tar Pits in California, which is a really dumb word because La Brea means the tar. So saying the Brea Tar Pits is saying the tar pits. So, but anyways, the Brea Tar Pits are not tar. Tar is a man-made byproduct. It's asphalt, natural asphalt bubbling up from the ground, and these asphalt pits would sometimes get water on top that's not as dense as the asphalt, and then animals would come down to drink and they get stuck in, they couldn't pull themselves out, and then predators and scavengers not wanting to waste a free meal like dire wolves would come and take advantage of that. Condors as well. California condors, which is our largest bird in North America today, and I'm going to get into that species here in a bit. That was another species we find a lot of, as well as many other extinct condor species at the La Brea Tar Pits. Now, when it comes to the idea of a hunter versus a scavenger, humans have a very bad idea. If an animal is a scavenger, like a vulture, we're like, they're a scavenger. So are we. We don't kill a cow every time we eat a hamburger. We go scavenge a hamburger that's already dead, right? Scavenging, so if you are a large predator, again, if you're something like a dire wolf, you're a hunter. But if you have an easy free meal, you're going to take advantage of it because why not? It's just smart business. Many dire wolves doing this, finding like a woolly mammoth stuck and sinking down into these La Brea Tar Pits, would say, oh, there's a free meal. They jump on it and be eating off it, and then they get stuck themselves too. So one of the largest assemblages in the La Brea Tar Pits is dire wolves. Tons and tons and tons and tons of skulls of them. So we know they were very successful, they were very prolific, and they are one of, if not the most common species found at the La Brea Tar Pits. But so when we're talking about these species, Colossal Bioscience is a company. They're based in Dallas, Texas, and they are trying to rewild and de-extinct animals, kind of like Jurassic Park. But they're not going back as far as dinosaurs. They're trying to say, hey, there's animals that are extinct recently, maybe, and a lot of them it's because of human-caused extinction. We should try to bring them back. In some cases, to help resurrect an ecosystem. I'll get to that in a minute. So to do this, and again, this bodes well for things like thylacines. Thylacines, we know for a fact in Tasmania and Australia, are killed off by people, and bringing them back would help that ecosystem be more intact because it's not right now. And we're the ones who caused that problem. So they had two specimens that they used. They had two individuals, Colossal Bioscience, sequenced the genomes from two individuals. One was 13,000 years old, and one was the inner ear bone from a 72,000-year-old individual. And so what they did is they took gray wolf cells. So cloning isn't magic. You're not creating life. Life exists, and life has a program. The program is DNA. Your genetics are the program to build you into what you are. But the life is that cell. So they took gray wolf cells and they basically kind of reprogrammed them with a gene editing program called CRISPR. You can look it up. It's very interesting stuff. They modified these cells so that basically that gray wolf cell was now a direwolf cell using direwolf resequenced DNA. Then from that they formed an embryo, and they transferred that embryo into a surrogate mother. They used a dog. They used a very large dog breed because they're like, we don't know how big these babies are going to be. So rather than using a gray wolf, if this is bigger, let's use a bigger than a dog breed. So they used a surrogate mother. And again, this is a technology that is used with humans. We know for a fact, you can have a surrogate mother. You can, if you're having difficulty with having children, you can have your DNA and fertilization and have another mother carry your baby, but that baby does not carry her DNA, just depending on how, and that's how it was done. So the surrogate dogs did not provide any DNA for this. It came, so the original cell was reprogrammed with, the original gray wolf cell was reprogrammed using CRISPR with direwolf DNA, transferred to a surrogate mother, and then they were born. So there are two males and one female, Romulus and Remus, named after the famous Roman, the Roman origin stories of ancient Rome. And then a female that came later on named Khaleesi. They waited to get the word out. They didn't want to get the word out right away, and I think that makes sense. I think that's very sensible. So the males are about 6 months old now. They're not being set free in the wild. They are being kept in a 2,000-acre preserve. And so this kind of technology is really helpful because it also advances medical and understanding of genetics. But there's a lot of people who are hugely for this and a lot of people who are hugely against this. So why is that? Well, we're going to get into this a little bit because when you're talking about a species, again, a species like a direwolf hasn't been around for a while, so what should happen? So if you remember, on Jurassic Park, Ian Malcolm, when John Hammond is trying to justify, here's why, look, what if you couldn't complain about what I'm doing if I made a flock of condors? And they bring up that example, and they say, Ian Malcolm is like, well, no, this is different. This isn't an animal that went extinct because of, the building of a dam or something or deforestation. And it's like, and so that's the example he gives. Well, here's the thing. Why are we the ones who are God on either way? Why are we the ones who get to say whether an animal goes extinct or not, whether an animal matters or not? Nature is always going to do its thing. Nature always finds a way to survive. Survive or go extinct is the rule of nature. For example, in the United States, peregrine falcons were highly endangered because of a pesticide that was making so their eggs wouldn't hatch called DDT. Well, even after that pesticide was banned, there was still a huge problem, and there was not many peregrines that were hatching. And another closely related species called the prairie falcon would sometimes interbreed with these peregrines. And they're closely enough related, this was considered a viable option. It's like, well, I'm not finding a mate. Hey, here's a mate with strong DNA that doesn't have that DDT poison in it. We can make fertile offspring together and pass on our DNA. So nature had a solution to the man-made problem. But humans were like, oh, no. Things have to be static and must stay a certain way. Life cannot change. The ecosystems cannot change. We cannot have hybrid falcons out there. And so some of them were killed, caught and euthanized, and some of them were trapped or pulled from the nests and just kept in captivity so they wouldn't be part of the breeding population. And on the one hand, okay, that's good, great, we're saving the peregrines. But on the other hand, We caused the problem, and nature was trying to come up with its own solution, and a viable one at that. We have the same thing now where you have polar bears up in the Arctic crossing with grizzly bears. And doing that, we're like, oh, you can't, that's just wrong. We can't have that. The polar bears are rare. They got to be pure. Hey, this is polar bears branched off from brown bears a long time ago, and now coming back to that, you're just finding a solution to a problem of not being able to find a mate. Nature finds a way. So you can be against it, and I'm not saying it's wrong to try to keep, species being the way they are. We have the same issue here in the United States. In the East, you have, in the Pacific Northwest, we have the highly endangered spotted owl. I've done a video on these. And then on the East and the South, you have the barred owl. These guys are closely related, but barred owls are more aggressive, and their range is expanded out to while now they're competing with spotted owls and out-competing them. And the government in states over and over again keeps making these culling laws. We're like, hey, let's go out there and we're going to pay hunters and let them go out and kill protected barred owls. So that they don't compete. It's like, really, in a dark tree, you can see the difference between a spotted owl and a barred owl accurately. And again, barred owls are just doing what they're doing. The world is always in flux. And so I have mixed feelings. On the one hand, sure, let's preserve the spotted owl, great. But on the other hand, nature is an arms race. And if one species, not because of humans, is out competing another, who are we to jump in? We have the same thing here in Utah. We have 3 deep forest hawks. We have the northern goshawk, and then in between we have the Cooper's hawk, and then we have sharp-shinned hawks. These are 3 closely related species, and they overlap in their range, and they overlap in what they hunt. Well, what we find is that sharp-shinned hawks are going down in numbers, and goshawks and Cooper's hawks have both been hunting them. But as the sharp-shins have been going down, Cooper's hawk numbers have been exploding everywhere. And, well, who are we to say that that's wrong? There is no waste in nature, so is it wrong for a species in the absence of another to pick up the slack? Same thing if we're going back to direwolves. We don't know exactly what caused direwolves to go extinct. But then we know that gray wolves picked up the slack. We know that when gray wolves came in, there was a competition. Competition for resources, competition for prey, habitat, range. Well, we don't know if gray wolves simply outcompeted them or if they were somehow better at doing what they did. You never know. Having come from the old world back to the new, maybe there was some sort of a disease where dire wolves swept through, and maybe that gray wolves brought a disease that the dire wolves got, and that swept through and had an impact. That's a possibility that you have to be open to. We have the same thing with humanity. You have different peoples from different parts of the world in the 1700s and 1600s coming together, and different diseases would spread through and would wipe out big chunks of populations, tragically so. So that is a factor that we don't normally consider. So when we're talking about the ecosystems of the world and of North America, where direwolves are from, the habitats have changed, but the argument for de-extincting animals actually plays a big role. So, for example, one of the reasons why they're trying to de-extinct mammoths. Mammoths up north used to knock down trees and consume them and just clear the steppe. So you had a steppe that was colder, stayed colder, kept the earth colder, and now what's happening, there's these vast carbon reserves underneath that as the trees are doing their thing, these things are being released as the earth is warming up. The permafrost is defrosting, and locked up decomposed carbon is going up. So people talk about climate change, and people talk about humans' impact. It is nothing compared to this permafrost defrosting, what it can release. So one of the things that mammoths used to do is, by clearing down some of the taiga landscape, is they made sure it stayed in what we call steppe. Steppe is just kind of like open, cold weather grasslands with permafrost underneath. It kept it that way. And so one of the concepts of bringing mammoths back is to keep the taiga forest at bay. Just kind of an interesting concept, bringing back an extinct animal to knock down trees. But it's biologically sound. So whether you're for it or whether you're against it, that is part of the reason for bringing back some of these. Now, some people say, well, if you have an extinct animal, is it from an extinct ecosystem? So people will say, okay, California condors. I was talking to my good friend today about this, and we're having some banter back and forth on this. California condors were built to scavenge off of megafauna. So in the United States, during the Ice Age, just a few thousand years ago, we had horses, zebras, camels, llamas. We had 6 different species of bison. One of them had horns 12 feet wide. We had 14 different species of antelope. We had 4 species of camels. 2 of them were as tall as giraffes, and 1 of them had saber teeth. We had multiple species of giant ground sloths, 2 of which were as big as an elephant. And again, we had 6 different kinds of woolly elephant. And there's tons of smaller animals, too, I don't have time to get into. They're not here now. So if you have a big giant herd of bison, a big giant herd of mammoths, and one of them dies, that can be seen from miles away by a California condor. It's easy. You go down, you scavenge. So the argument is, well, California condors are really a relic from a dead ecosystem, an ecosystem that's gone. And that is a valid point, but you got to have the full picture. Used to have this many California condors thousands of years ago, but 100 years ago, they were down to this, but they were stable. In California and in Oregon and in Washington, they went from scavenging the megafauna of the Great Plains to hugging the coast, where they would follow along and they would do 2 things. They would look for dead, washed up animals like a dead whale, a dead seal, something like that. You just soar on the coast, you get big updrafts, you find something dead, you go and you eat it. But they also would follow the salmon runs, just like and along with bald eagles. So bald eagles, just like grizzly bears, know when the salmon are going to swim upriver. And once those salmon spawn, they begin to wash downriver. So when that happens, there's dead fish everywhere. And that was the right time to stock up on all that protein. California condors, it is documented in the 17 and 1800s in mass in Oregon and Washington. They came in mass, thousands of them. Meanwhile, by the 1900s, California condors almost went extinct. So even though their original ecosystem they evolved to be in shrank, they were stable and solid through the 1800s. But once the 1900s hit, people started shooting them, and also they started getting lead poisoning. When you shoot a big game animal, you shoot an elk, you shoot it, it dies, you go and you gut it, and you leave the gut pile out, and you bring the meat and the hide home. Well, that gut pile has lead in it. They have done tests. Peregrine Fund has demonstrated this beautifully, firing a bullet through just like a milk jug full of water, and the amount of lead that sloughs off and goes to the area of least resistance, which is the guts, is where it is. So over time, condors can handle just about any disease when they're eating dead stuff, but they cannot handle lead. And that is one of the biggest causes to the California condor decline in the past 100 years. People shooting them illegally. Well, it wasn't illegal in the past, and then it became illegal, but people still did it. People shooting them, and lead poisoning. So here's an animal that had this much during the Ice Age, and then they were stably down to this much by the 17 and 1800s. They were doing great, and then the 1900s, they tanked. So the idea of doing that is pretty incredible. The fact that, hey, if you can de-extinct condors and add to their genetic diversity, they are still here. We don't need to bring them back from beyond the grave. We can just increase their genetic diversity. And this is something that Colossal Bioscience is doing right now. They specifically have also brought back some red wolves. Red wolves are not extinct, but they have increased the biodiversity of red wolves that are highly endangered by bringing back and cloning some of them and branching them out. So this is a very helpful thing for species that are still around today. So one thing I didn't bring up, so what happened, where did the dire wolf come from? The dire wolf at Skinwalker Ranch, the supposed dire wolf. Well, a few years ago, while out doing a survey of the river, some of the team came across a dead animal in the river. and they didn't think much of it, and they gathered it up for me to take a look at later on. It was so putrid. They just got the jaw for me. And then when I saw it, they sent me a picture of it. I'm like, oh my gosh. I mean, the morphologically, this looks like a juvenile dire wolf, a subadult dire wolf. The shape, the number of teeth, angle, everything, it looked like that. I'm not saying that's what it is, but I'm like, this is something special. And I'm like, can you go back and get the rest of the skull and the rest of the body? So, it was like a week been by. They went back and they got the rest of the skeleton. Unfortunately, the rest of the skull washed down river. So we took that jaw. We took samples from the teeth, 2 teeth, went to Colossal Bioscience. They sequenced the entire genome, and I cannot tell you what it is yet. You will find out if you watch the Skinwalker Ranch TV show, the next couple months coming out, might even be this month, they'll reveal results. So, but why I'm bringing this up is a lot of people have been asking, is these cloned dire wolves that Colossal has produced, are these from that sample? That I can tell you, no, they are not. Colossal had already sequenced these 2 complete genomes of these 2 individual dire wolves. They had already done that beforehand, and that's why when we shipped those teeth samples to them, they were the experts to be able to tell us, is it a dire wolf, isn't it, or what is it compared to other canines that they have also sequenced. So I cannot tell you the results on that at this time. But again, if you watch the Skinwalker Ranch, The Secrets of Skinwalker Ranch, it's on the History Channel. It will be revealed here in the next few weeks, next few months, and you'll have the answer to what it is, and it's pretty wild, pretty interesting stuff. So, but I just wanted to say that sample that I have that we got from the ranch, that is not where the DNA came from to produce these 2 males and 1 female dire wolves that Colossal Bioscience has made. So, is it right or is it wrong to do this? If you want to talk theologically, some people say it is wrong to create life. Well, nobody's creating life. You are still having to use an original living cell. So if you have some sort of a theological reason against this kind of work, you have to understand the living wolf cell already existed, and they just programmed it, use the word loosely, with the CRISPR gene editing software and reprogrammed it with DNA from a dire wolf. So they're like, okay, cell, build a dire wolf instead of building a gray wolf. But the cell was already a living thing. So if you have a version of that, nobody is creating life. But as far as is it right or is it wrong, please understand, no matter what, this subject has many nuances. And again, that's why I brought up the California condor part of this, because California condors, you could be like, well, they're part of an extinct ecosystem. Well, they are, but they had stabilized, by the 1700s. They had stabilized to a smaller way of life, hugging the coast and following the salmon runs and following the dead stuff on the ocean. So, it was partially human caused. And so maybe there is a precedence to bring them back from the levels they're at now. So I think there is no harm and actually potentially great benefit to trying to bring some of these animals back, even if they are not put back into the wild. Part of the justification for this kind of work is to reconnect and to recomplete ecosystems that are no longer intact right now. But even without, for example, dodos are a very recent extinction. Dodos lived only on one island, in the island of Mauritius. And then humans started coming to the island. They were the largest animal on the island. There was no natural predators big enough to harm them on the island. Dodos evolved from pigeons. Specifically, they came from the Nicobar pigeon, the Samoan tooth-billed pigeon, and the Victoria crown pigeon. They didn't come from them. Those are their closest cousins that we have alive today. So the question is, do we bring back the dodo? Well, if you brought back the dodo, you could not release it back into the ecosystem of the island of Mauritius, because the very things that harmed them, so you had several specific things. You had, first of all, people killing them, but people wouldn't do that anymore. But then you had rats Dodos nested on the ground. Rats would come and eat the eggs and eat the babies. They had no protection. And then you had later on pigs caused huge damage. Monkeys also released on the island, and they would eat some of the eggs and eat some of the babies. And you have dogs and things like that. So you have ground predators that didn't exist there before. So the dodo, that there is no longer a precedence because the habitat where it lived cannot sustain dodos today. Food-wise, it could, but there's too many ground predators, so dodos would never be able to. However, I am totally in favor, for better or for worse, even if it's a bad idea, even if you got Jurassic Park going through your head, I would love it if dodos were brought back from extinction. I think it would be incredible. We just missed them. So I would love to see that. So some of these animals, again, the justification for trying to bring them back is to reconnect and recomplete an ecosystem that has been broken, especially if it has been broken because of human problems like the thylacine in Tasmania. But some of them, it's just like, I think it would be wonderful to bring them back. And again, just like these dire wolves today, again, these dire wolves are now living in a 2,000-acre preserve of their own. It's really pretty neat. That location is not being disclosed because they don't want anybody to come in and harm them. Some nut job coming in saying, no, this is wrong, I'm going to kill them. So I think it's really neat that we have them and what we can learn from them. And I'm really excited about what Colossal is doing. I really do hope it's a long shot. It'll take a lot more work, but very, very hopeful that they can bring back thylacines because that would be absolutely incredible to see. So, I hope this kind of clears up some of the things of what exactly happened. Oh, yeah, I'm going to say one more thing, too. This is kind of important. Some of the people are saying, oh, well, these dire wolves, they're 99.5% dire wolf, and the rest is gray wolf. And so they're not the real thing. They're not the real thing. It's like, hello, we've sequenced Homo sapien, human DNA, and quite a lot of us, a sizable chunk of us, have 0.5% Neanderthal DNA. Does that mean you're not a real Homo sapien? You're not a real human because you have 0.5% Neanderthal. So you're not a real human. No, you're a real human. We have this happen in the wild too. We have it with falcons. I do falconry, and if you have a gyrfalcon and a saker falcon, you cross them. That's a gyr-saker hybrid. But if you have like 1/16 gyr, 15/16 saker, that's a saker falcon. It looks like a saker. It is a saker, but it's got 1/16 gyr in it, and it's passing that DNA on, but you're not noticing, you're not seeing it. Same thing. I don't look like a Neanderthal, but maybe I have 0.5% Neanderthal DNA that I'm carrying along and passing on. But you know what? I'm a Homo sapien. And if a dire wolf that has been resurrected and cloned and brought back from extinct DNA is 99.5% dire wolf, it's a dire wolf. The fact that the original cell was made from a gray wolf and then reprogrammed with CRISPR, and it's still a dire wolf. It's still the program that it was made. So it's pretty fascinating. A lot of people are very excited about it. A lot of people are very upset about it. Love to hear your comments down below. Let me know your thoughts. Let me know your perspectives, no matter how outrageous on either end of the direction. Again, I think we should be cautious with this kind of technology. I think it's incredible, and I think it has wide-ranging applications for helping to save currently critically endangered species and for bringing back extinct ecosystems by reconnecting with animals that are extinct. And again, for species that can't go back into the wild, again, I would love to see a living dodo or a living thylacine, even if some of them can't go back into the wild. So anyways, I hope you enjoyed this video. I hope you learned new things. And always remember, life is a gift. So never stop learning and never stop exploring. We'll see you next time.